Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to take a break from my ongoing series of coding the combat system for a viewer's game. I have asked the person whose game it's going to be a question today, and they haven't got back to me by the time that I'm recording my video, so I'm going to take a break and talk about something else. I'm going to talk about this simple map generator that I have created, which creates a random map that looks like the physical maps that you might see in an old atlas. I say physical maps because traditionally there's two main types of maps of large areas. There's political maps, which show countries and then the subdivisions of countries like states or provinces or whatever. And then you have physical maps, which show height above sea level, or in the case of the sea, the depth of the sea, the distance to the seabed. And I've created a program that generates maps that look like one of the maps you would see, one of the physical maps you would see in an old atlas. So here's one where we have a mainland, we have a mountain range up here, and then we have a sort of smaller island here, and we have some isolated islands, and then a chain of islands down here. If I restart, we have again a mainland up here, and then a smaller island. This one is sort of just a chain of islands, and so on. This one's mostly land, and then there's a sort of inland sea or lake over here. So I'll show you the code that allows this to happen, but before I do that, I might want to talk about, well, why would you want to make a map like this? What is the point of it? Well, of course, there's only a point if you're going to make a game in which the players travel over a wide area. It's quite possible to have a game that takes place entirely within a single city or town or a single dungeon. But sometimes you may want to have the characters traveling from place to place. And if you want to have them traveling from place to place, you could have a set map that's the same each time. But discovery and exploration are a big part of the fun of games like this. And so you might want to look at having a random map, and this is a sort of simple way to do it. I probably wouldn't make one of these maps your entire world. I might make it like a section of the game, and then they travel. Perhaps they start on this map and then they travel to another one. That one's sort of all mountains, and then maybe they travel to yet another one. And the reason I wouldn't make your entire world one map is that you might not have places to put all of the features that you want. So let's talk about that. Why would you want to make a map that shows height above sea level or the depth of the ocean? That's a traditional thing to put in maps of the real world, but why would you want that for maps of a game? Well, apart from just maybe you like the look of a sort of old, an old traditional sort of atlas map, but more importantly, your encounters, the things that you want to put in your game, probably require a particular environment. So you've probably got an encounter, you might have an encounter where the players come to a small island, for example, and you might have another encounter where the players are in a fairly civilized sort of settled area. You might have another encounter where the players are in a sort of isolated wilderness type of area. Perhaps specifically it's a forest or or the mountains. Even encounters at sea, you've probably got some sort of distinction between encounters that happen in more sort of settled areas where you might meet with sort of, friendly merchant ships or something like that. And then there might be sort of wilder areas where perhaps there are pirates. And then there might be still more wilder areas where really strange things happen. There's sea monsters and so on. And it's pretty easy to to match those encounters to places on a map like this. You want to have something on an island? Well, let's look for one square of land surrounded by sea, and that will make that is clearly a small island, an isolated island, and you can have the encounters that you think of there. How are we going to? Where are the stranger parts of the sea where the sea monsters live? Well, it might be the bits that are furthest away from land. It might be the deepest parts of the ocean. Where are the settled and civilized areas? And so the sort of stranger parts might be the deeper parts, or the parts that are furthest away from land. They tend to be the same areas anyway. And then the more perhaps you have, if you're close to land in shallow water, you have more civilized encounters. Then the pirates start sort of a little bit beyond the reach of the law, but still where there's shipping, right? That tends to be what happens in real life. Cities and settlement tend to be along coasts. And what's a coast? Well, it's an area of land that is next to water. It's a land square that's next to water squares. Either that's the sea. Sometimes, just as you have an island, well, that's a single square of land surrounded by water. Well, you can have a lake. Perhaps you have an encounter that only happens in a lake, which is a square of water surrounded by land. Where are the cities? Generally on the coast. Where are the settled areas? Generally the lower elevations. So in this, the sort of the greens basically. And then where are the more out of the way places? Well, it tends to be what on here is coloured sort of brown and pink. So you might say that, well, just to be arbitrary, you could say, well, this shade of green and this shade of green represents a sort of civilized areas, plains, cities, towns, etc. Maybe the next one up, this sort of yellowy area, that represents, maybe that's things like forest or sort of more sparsely settled areas. And then the browns, that might be, the light brown might be hills, the dark brown might be mountains. And so if you have a sort of lost monastery where there's a sage living on top of a mountain that you have to go visit, well, they're in one of these dark brown areas. You have a little fishing village, well, that's going to be on a land square with a sea square next to it. And so you can have these set encounters and specify that they have to happen in particular places. And that creates, and then you can it's easy to imagine sort of shipping routes. For example, you might say, well, I'll randomly say that each of the dark green areas, there's a city or town there in sort of 1 in 10 of them, or there's a total of 8 cities or towns. And then you can say, let's say every city or town that's within a certain distance, let's say within this size distance, something like that, then it's possible to get a ship to travel from one to the other. And so that sort of sets up, where the shipping routes are. And you can say, well, the ship will go in a straight line. Or you can tell the ship where to go. And like, for example, let's say you're here and want to go here. You could go in a straight line. That's going to be a lot quicker, but it takes you across this deep sea. Maybe the deep sea is more dangerous. That's where the sea monsters are. It might be safer to go from here, sort of down to here through the shallow water, or maybe, sorry, that probably doesn't work. Let's say we go from here down to here and then sort of cut across there. So you can see that if we go across this route, it's a lot longer, or a little bit longer, but we're sort of avoiding that more dangerous deeper water. And so you have this sort of decision that the player might have to make, and that's just been created by by the random chance of, we just happen to have this little patch of deep water here. So that's the justification for having it. Apart from just, it looks kind of nice, and it would. I mean, this is a very simple display. I've just got plain squares. What you probably would do in real life is design more detailed sort of pictures with little waves on it or something, or in the case of the sea, and then little, hills or whatever for each of the land bits. But even looking at this sort of crude version that I just did today, it still looks, it still sort of looks pretty good. It certainly reminds me of the maps that I was thinking of when I created it. Anyway, having said that, I'll spend the rest of the video showing you how the code works. I will say that there is a big problem with this method that I'm using, and you might have noticed it already, but I'll tell you in case you haven't, and that's that everything runs from sort of southwest to northeast. The land sort of goes in this direction. You very seldom get land going in the opposite direction. The sort of the area of shallow sea kind of goes up like this, and this one goes up like this as well. And that is a function of how, and this happens again, you've got the land up here going in this direction, we've got more land going in this direction. There is a sort of roughness to it and a randomness to it, but it does always do that, and that is a big disadvantage. But this is a very simple method. I can if I have time, because of course I've got this big project that I'm mostly doing, but I can show you other ways that make for more varied maps. But that is a big disadvantage of this method. But I'll I won't sort of explore that. I'll just spend the rest of the time showing you the code. Eventually. Oh, hang on, I'm clicking the wrong button. Okay, here we go. So it's quite simple. We have 3 pages. Let's zoom in a bit. Sorry, passages. Initialize, where we set up the variables. Generate map, where we have an array which is called map, $MAP, and we work out a height for each square in that 2-dimensional array, and then a place where we print the map, which is not all that complicated or interesting, but I'll spend most of the time on the generating map. That's probably the most interesting part of it. So, initialize, there's a little note as to where I got the colors that I used in the map. I got it from a person on DeviantArt. Usually I use X and Y as temporary variables. This time I'm using X and Y as the dimensions of the map, with X being the east to west dimension, the width, and Y being the north to south dimensions, the height. We have an array which is it's the codes for the colors that we're going to use. I've talked a little bit about colors before, but when you in HTML, the language that is the sort of basis of how websites work, and Twine always creates websites, so it uses a lot of HTML. In HTML, the way colors are determined is you have 2 numbers that tell you how much red is in it, 2 numbers that tell you how much green is in it, and 2 numbers that tell you how much blue is in it. It's called an RGB code, standing for, of course, red, green, blue. It uses some slightly unintuitive mixing of colors. Like if you did sort of high school art, you would say, well, the 3 primary colors are red, blue, and yellow, not red, blue, and green. And green is a mixture of yellow and blue. Well, it's sort of, yeah, it works slightly, it is a slightly unintuitive thing, and I won't go into it in great detail, but essentially, it has the amount of red, the amount of green, and the amount of blue. Oops, sorry. And the amount of blue, and each of those is a number. And you might say, well, James, no, they're not numbers. Some of them are letters. At least half of them are letters. Well, the way that it works, confusingly, is it's in base 16. Our counting system, the one that we use, is base 10. And what that means is there are 10 different characters that you can use to write out a number. Those 10 different characters, of course, being 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that there's a total of 10 different ones there. And then, of course, we don't have a new character. We start going 1, 0, 1, 1, 1, 2, etc., etc. But there's nothing sort of objectively better about 10. We just use 10 basically because we have 10 fingers. We could use any other base, and the RGB codes for colors use base 16. And because we only have 10 characters for numbers, they have to make up characters for the other. Like, we have 10 characters, they're using 16. Well, that means they have to make up 6, and they use A, B, C, D, E, and F for that. A means 10, B means 11, C means 12, and so on up to F, which is 15. So 3C, 9, 6, and AA are all 2 character numbers, but they're in base 16. Again, it is slightly counterintuitive. It's to do with the way that computers store information. They store information in a binary format, meaning it's information is stored in one of 2 states, usually represented as 0 and 1. And 16 is easier to work with than 10 because it is a power of 2. 16 is 2 by 2 by 2 by 2. So you can represent it with 4 pieces of information that are each of which is either 0 or 1, essentially. So these are the codes for the colors. Anyway, FF is pure white. So that's having FF is the highest you can have, and 00 is the lowest. Pure black is 000000. Pure white is FF. Pure red is FF0000. So it's the red is turned all the way up, and then the green and blue are all the way down. And then pure blue is 0000FF, and so on. So we have that array that tells us the different colors that we're using. There are 13 just because that's an arbitrary number. It just happened to be that this palette that I found had 13 different colors in it. We have map. This is probably the most important variable. It's a 2-dimensional array, each of which stores the height of a particular location. Because it's a 2-dimensional array, we have to have a for loop that goes from 1 to x, remembering that x is the width of the map, or the east-west dimension of the map, setting up each slot as itself being an array. We have $range, R-A-N-G-E, which gives you the number of possible heights. $range has to be the same as the number of elements in the $color array. I mean, it doesn't matter if you have more slots in the color array than you have $range. Just the extra ones won't be used. But if you had fewer, it'll look weird when you try to display it. And then I've got a note that says what I'm using as temporary variables, Z, Y2, and X2. And just a note that X and Y are used for the dimensions of the map because I normally use them as temporary variables. So once we've set all that up, we generate the map. So we do it in 4 parts. we generate the lower left-hand corner. So we set map 1, 1 to be a random number between 1 and range. Then we do the left-hand column. Then we do the bottom row. And then we do sort of everything else. And you'll see why it's done in that in 4 different ways as we go through. So the left-hand column, we have a for loop that goes from 2 to y, not 1 to y, because we've already done map 1, 1, which is the bottom corner. And each square, its height is going to depend on the height below it, because of course you don't just get, you can't just sort of make each one a random height, because then it'd just be a big mess. You wouldn't get any proper looking land masses or lakes or seas or anything. It would just be a big sort of piece of static. So you have to have the heights of things be similar to the heights of things around it. So in the left-hand column, everything's going to depend on what's below it. So we look at, we're setting map 1z, and we're always looking at map 1z minus 1. So in other words, we're always looking at the square immediately to the south of the square we're filling in. And here's how we do it. If the square to the south has a height of 1, the very deepest ocean, then we set the new square to be either 1 or 2. If the square to the south has a height of range, i.e. it's the very highest mountains, then we set it to be either range minus 1 or range. So you can see that those two are sort of symmetrical. If it's the very bottom, set it to one of the 2 very bottom heights, and if it's the very top, set it to one of the two very top heights. Otherwise, if it's anything else, make it a random number between the square to the south's height minus 1 to the square to the south's height plus 1. So in other words, if the square to the south has a height of 3, then this one can be either 2, 3, or 4. So normally we have 3 possibilities, but if it's if the height is 1, we don't want to ever set it to 0, and if the height is range, we don't want to ever set it to range plus 1. So we have only 2 options when we're at the sort of extremes. Then we do the bottom row. The bottom row works almost exactly the same, except we're referring to the square to the west, not the square below, because this is the bottom row. There is no square below. So again, we go from 2 this time to x, because we're going east to west. If the square to the west is 1, then the new square is 1 to 2. If the square to the west is the maximum height, then the new square is either the maximum height or 1 below. Otherwise, it's either the square to the west minus 1, the same as the square to the west, or the square to the west plus 1. So that's fairly easy and quick. The rest of the map is a little bit more complicated, but it's not it's not super complicated. So we have 2 for loops this time, x2 and y2, and they're going to go from 2 to x and from 2 to y, not from 1 to x and from 1 to y, because we've already done every square where x is 1 and every square where y is 1. So here's what we do. We look at the height of the square immediately to the west minus the height of the square immediately to the south. We set z equals map x2 minus 1 y2 minus map x2 y2 minus 1. So take the height of the square immediately west and subtract the height of the square immediately to the south. And then we're going to do different things based on what that result is. First possibility, that the difference is 2. In other words, we might have 4 to the west and 2 to the south. If that's so, we set the map square that we're looking at to be the same as the map square to the west minus 1. So let's say we have 4 to the west and 2 to the south. We set the height to be 3. So it's still within range. And that stops there being too big a leap in heights. It means there can only be from one square to either the north, south, west, or east. It can only be different by, the height can only be different by 1. It can be the same, but it can only be 1 higher or 1 lower. So well, let's say as I say, 4 to the west, 2 to the south, we make it 3. What if z is minus 2? Well, that's more like 2 to the west, 4 to the south, for example. Well, in that case, we set it to be the square to the west plus 1. So if we have 2 to the west, 4 to the south, make the square we're filling in 3. All right, what if z is either 1 or minus 1? Well, then we have a choice of 2 different things we can do. We either set it to be equal to the square to the west or equal to the square to the south. So let's say the square to the west has a height of 0, the square to the south has a height of 1. That means this square will have a height of either 0 or 1. Otherwise, what if the difference is 0? What if we have 3 to the west and 3 to the south? Well, then we set the square that we're looking at to be a random number between the square to the south minus 1 and the square to the south plus 1. We could have used the square to the west because in this circumstance, the square to the west and the square to the south will be the same. We just happen to have used the square to the south. So if we've got 3 to the west and 3 to the south, set this one to be either 2, 3, or 4. Now, this is a different way to deal with the extreme ends. I just arbitrarily used a different way here than on initialize. And that is, do it this way, but if it's 0, set it to 1 or 2. So the point of that is it can only be 0 if the two squares are 1 and then we happen to get the bottom of the 3 possibilities. So if it's 0, well, if the two squares are 1, we want it to be 0, 1 or 2, but we don't want it to be 0, so set it to 1 or 2. And then we have the same problem at the opposite end. If the map that we've set out is range plus 1, well, we don't want to go out of range, so instead set it to either range minus 1 or range. So what if it's not 0, 1, minus 1, 2, or minus 2? What if it's greater than that? Well, then print an error message, because that shouldn't ever happen. If it's only ever changing by 1, and if when we get a difference of 2, we make the new square the middle height, that shouldn't ever produce leaps of 2. But I put that in there so that just to sort of prove that we're not getting that. And then we print the map. Well, printing the map's not really all that interesting. It's just a table. We go from, normally you'd think you'd probably put X first and then Y, and you'd go from 1 to Y, not from Y down to 1. The reason we do that is because think about how we mark grids. The X version, the X what's the word? The X variable goes sort of to the right. So that's X equals 1, that's X equals 2, that's X equals 3, that's X equals 4. The Y version goes up. So that's Y equals, if let's say that's 0, 0, that one's Y equals 1, that's Y equals 2, that's Y equals 3. So when we're printing it out, we're going to be printing the top value of Y first. So that's why we count down the Y variable. The reason we do the Y variable first is think about how printing works on a computer. We might print here, then here, then here, then here, then here, then here, then here. then we go down a row. We don't print down like that and then to a new column. And the reason we don't do that is probably basically because computers were mostly developed in the United States and not in China, and people in America write in that order. And there's nothing inherently in a computer. There's nothing in the design, in the nature of a computer, that means it should print like that. It's just we happen to have people who developed computers happen to have written that way. So we print everything that's on the same row first. In other words, we print everything with the same Y value first. And that's why we have 4Y up here and 4X here. And we print this, and I'll show you an example of what that might look like. And that'll make it a lot easier to understand what's going on. Okay, so this command, it's obviously going to be different depending on what's in here, but it prints a TD, which is the beginning of the cell of a, sorry, I should say we print a new row because this is a HTML table. We have a new row every time we increment Y. So we have a cell here, BG color, which is background, equals quote hashtag, and then we have this. And what is that? Well, it looks at map x2, y2. In other words, it looks at the square that we're currently displaying, and that will have a value. Let's say it's 5, and it looks at that slot of the color array. So it'll get something out of the color array like maybe this, or if it was 6, it'd be that one, which is the pure white of very shallow water. But anyway, it prints that as the color, and then it says have a height of 3 pixels and a width of 3 pixels. And then we just close the cell. We don't actually print any text in the cell. All we're doing is printing our cell that's 3 by 3 pixels, hopefully, and has a particular BG color, which is background color. And that's all we do for each cell. If we were doing a more professional looking display, we probably wouldn't just be printing a cell of a, we probably wouldn't just be printing a blank cell with a flat color. We'd probably have a picture stored in the art folder, and we'd load up a picture for each square to make it look a bit more detailed, a bit less pixely. But this is a quick thing that I've done, and that's how we display it. And that's how you generate a simple map, because of the fact that you generate everything up here, then you generate everything along here, and then you're sort of going up like this. The algorithm does tend to make heights be similar as you go diagonally up, and that's why we got that effect where the land is sort of tending to go diagonally up. So you might have, let's say, a 2 in this square, and then this one will be a 3, and this one will be a 3, and then that one will be a 2 again. A lot of the time, it just sort of means the odds are, given how it's being how things are being placed, the odds are that you'll tend to get lines of same or similar height that go sort of up and to the right. And as I say, there are ways to deal with that. I will, whether I sort of do more in this series or just go straight back to the main series where I'm doing the combat system, depends on what people are interested in. But I will leave it there for now. I hope that was useful or interesting to at least some of you, and I hope you tune in next time.